All right, so up next, we are joined by Jeremiah Grossman, CEO of Bit Discovery, for his session, Attack Surface Management from CISO to CISO. And the reason I said the other one like that is because you're supposed to be imagining dollar signs all around it. Jeremiah, off to you.
Thank you very much. Let me share my presentation here. Let's see here. All right, we're looking good?
Yes, all clear.
Great. All right, thank you everybody for the time. I'm going to be talking about information security, attack surface management, and money. So that'll be a little bit different presentation than you normally might be seeing from me. So a little bit more about myself. I'm Jeremiah Grossman. I'm CEO of Bit Discovery. Bit Discovery is in the attack surface management business. We'll talk a little bit more about that. But I have over 20 years of experience in information security. Prior to founding Bit Discovery, I was the founder of White Hat Security. That was all about application security, which you've heard a lot about here today. I was also the former chief of security strategy for SentinelOne, an endpoint, an EDR company focused on endpoint. And I'm also a black belt in Brazilian Jiu-Jitsu. So I have a lot of diverse interests. So let's jump into it because we only have roughly 30 minutes. We'll see what we can get to, and please let's hear some questions because I'm going to push everyone thought process forward as far as some of the ideas I'm going to share here. When you're starting an information security program, and most of us will not have the luxury of starting an information security program. Usually when we go into a company, we take over one and either have to scrap it all or improve upon it. Generally speaking, though, the first question anybody asks or should ask in any program is, what assets do we own? Because in very simple speak, it can only secure what you know you own. Attack surface mapping or asset inventory, you'll find, is the very first thing you're suggested you do in every security practice, standard, policy you see. It also happens to be the thing that no one ever really does or does well. And there's a variety of reasons for this. Let me define some terms here first. When we talk about attack surface, what is the loose definition? What do I mean by that? Attack surface in this context is what a target looks like, let's say a company, an organization, a government looks like from an external perspective, the external network attack surface. Hosts, various host servers, anything that can be seen from the public internet. Of course, IP addresses, open ports, you might find network printers, websites, mail servers, all of that, anything that's remotely connectable on any service, that's the attack surface. So when I say attack surface, that's what I mean. When I say an asset, many different assets make up an attack surface. So good to define terms before we get complicated. For those that have been in information security for more than 5 minutes, we'll quickly appreciate that the vast majority of organizations out there do not have any idea what they have exposed to the internet. They really don't have a list of their websites, their mail servers, DNS servers, their VPNs, databases, or anything really. And there's a number of reasons for this that we'll get into in a moment. But while InfoSec is about 30 years old, depending on where you start counting, we've gotten away with this for a while because usually the adversaries, weren't really going after the secondary and tertiary assets that we had out there until very recently, maybe the last 2 years, or ransomware and other attacks became significant. That what we're hearing now today at Bit Discovery from a variety of sources, that a significant number of breaches that are being reported right now have something to do with their previous unknown asset. We're getting hacked by assets we could have patched, should have patched, but we're not, and we suffer breaches. Now, it's one thing to get breached for a 0 day or something like that. It's quite another and quite embarrassing to get hacked by an asset that you didn't even know you owned or were responsible for. Here's an example that I like to use a lot. Everybody brings up the Equifax hack. And if you've read the articles and all the stories, you'll come away with one overriding theme. The reason that Equifax got hacked is because someone exploited an unpatched Apache Struts vulnerability on some website that Equifax had. While that's true, that's an incomplete and rather superficial understanding of the problem. when this hack went down, Bit Discovery had a platform to go look at what does Equifax look like from the public internet, because we have the ability to look at the attack surface maps for any company or organization in the world. One thing we noticed is that, well, they had a lot of websites and a lot of websites with Apache struts, and most of them were patched, except the one or two that got hacked. So we asked them internally, this was many years ago now. So we asked them and they said, well, we would have patched it if we knew it existed. And this was verified later on in the FTC complaint in the subsequent lawsuits that Equifax did have a patch management program. They were patching the strategy struts vulnerability. Only the website that was hacked wasn't part of that vulnerability management program. So in very simple terms, if Equifax and many other companies had a good evolved attack surface map, if they did an asset inventory, they probably would have patched, and this would not be a story, and they would have saved themselves hundreds of millions of dollars in breach costs, and hundreds of millions of people wouldn't have had their data stolen. Now, this seems like a very simple problem. Create an attack surface map of an organization, find out what they own. It does. It sounds simple, but I promise you it's anything but. From my perspective here, I've gotten to work on a lot of technology problems, whether it's in application security, endpoint, or whatever. Attack surface mapping, for reasons that I'll touch on in a moment here, it's the hardest problem I've ever had to work on. Different assets of any particular company, they can be on different IP ranges, hidden under different domain names that you may not be aware of, that someone registered that's not in one spot. They might be on different hosting services provider, different ISPs. Some might be in GoDaddy, some might be in AWS. No one really knows. A company is not just one company and one brand, it's multiple brands with multiple subsidiaries and partnerships. So that confuses it, because sometimes the ownership is shared between organizations. Sometimes there's consolidation, sometimes there's spin out, but it's really disorganized all over the place. For those that are interested in like a technical deep dive of what makes attack surface management hard, I put up a link to a blog post out there where I went through all the gory technical details. When you're trying to solve this problem, the different technical things you have to account for to really compile an accurate and up-to-date attack surface map. Not the least of which, what we're finding is when we're monitoring an attack surface for any organization, there's about a 1 to 5% drift in the change rate of an attack surface map, meaning assets go up and down, or ports open and close, and the software that's running on every asset changes, or it's patched and configured differently. So there's change rate that's happening all the time. So you really have to monitor these things 24/7. So to describe how Bit Discovery went about what we did, it's important to first touch on how everybody else does it, or even how we did it over time. Normally, when you first go after an attack surface management problem or an asset inventory problem, you go, well, logically, we'll start with the domain name of the organization and maybe collect as many of the IP ranges that they have. And you use that little bit of C data to start crawling the internet, touching every asset on those ranges or on the subdomains of that domain, and you get a lot of data back. The process ends up being really, really slow, false positive and false negative written. And after you fail a few times, usually most people give up, which is why all the tools out there are slow, tedious, and largely incomplete. So Bit Discovery didn't want to be deterred by this, at least the founders behind it. So we've decided the audacious plan to, what if we just downloaded as much of the internet as we possibly could? All the DNS data, port scan the internet, like all domain names, all whois, all host names, all IP addresses, all ports, touch everything on the internet, scan it all and bring it into one master database, and then augment that master database with more internet data from other third parties. So right now, Bit Discovery is tracking about 6.5 billion or so internet facing assets. And we have about 100, 150 or so third-party data sources that augments our own. When you really think about it, it's the largest data set of its kind, information about the internet. Now, what happens is when you have this pile of data, you can search for domain names or IP ranges and do very nuanced searches to pull everything out very quickly for a single organization, which is why we're able to create an attack surface map for everybody in an automated fashion, because we have all this data and it's updated regularly. So now we've touched on attack surface mapping, what it is, why it's important, generally how to do it. The next question, after you want to, if you're running an information security program, the next thing you want to do beyond just finding all the assets is, what is each asset worth? It's another thing that we skip for some reason in information security, probably because it's really hard and no one standardized a way to do it. But the idea is that you want to spend an appropriate amount defending an asset. You really don't want to spend $1 million protecting an asset that's only worth 100,000. And subsequently, you don't want to protect an asset that's worth $1 million by only spending $1,000. So we need appropriate levels of spending on a per asset basis. Right now, all we know is the organization is this big, we have this many assets, we have this much money, and do the best we can. That's the extent of the sophistication, and we can do better. So we really want to know the value of each asset so we can find the problems and spend the appropriate amount to reducing the risk of the business in a justifiable way. The problem is that there is no standard currently out there anywhere in the world for appraising the monetary value of an internet-facing asset. We don't know how to value a website, a mail server, a VPN, or anything else online. The accountants don't know how, the lawyers don't know how, the SEC doesn't know how. It's brand new greenfield territory. So what we really need to do in InfoSec, in my estimation, is we need to find all the assets, and we need a good enough model to assign a monetary value to each asset, because only then can we talk in business terms and make progress, spend the right amount of money, addressing the right risk, and reducing it in a measurable way. So this is the one that Bit Discovery has been working on the last 2 years. In the meantime, this is where I get to poke fun at the industry that we're in. Like I mentioned before, we're roughly 30 years into InfoSec. Many of the world's brightest minds give us this matrix of security products that we spend over $150 billion a year on. And we can only hope to ask ourselves this one snarky question: are we secure yet? And you only have to follow Twitter a little bit or follow the news just a little bit to know that, well, it's not. Everything seems to be hacked all the time, and I'll touch on that in a moment. So with all this money, all this venture capital, all these brilliant minds, this is the current state of risk management, what we refer to as traffic signal security. The best our industry has to offer, whether you call it next gen or anything else, is red, yellow, green traffic signals that we're supposed to make very important business decisions. If an asset or a set of assets has a grade C or a B, or a CVS score of 4.2, what are we really supposed to do about that? Do we fix it or do we not fix it? Do we spend this much or that much? Do we things now or do things later? If you look at it like from any CFO business manager's perspective, how do we look at this and make good, justifiable decisions? It's impossible. I should say at the same time that this is probably the best we could do so far, because we're missing those pieces of this information. So let me move on from this. So now, after we spent $150 billion a year, we spent 30 years, all the things that we really know is everything is hacked or at least vulnerable all the time. Now, I think we can at least solve the first problem, meaning we don't have to have everything hacked all the time. But we're going to have to deal with a certain number of vulnerabilities out there forever, because to think otherwise is to say we have to fix every vulnerability now and soon. Probably not going to work out. So when I am asked the question, why are things still hacked after we have brilliant minds across the industry? We spend a lot of money, a lot of time, and a lot of energy. We have conferences and events like this. 3 reasons. Most companies don't know what assets they own. They don't know what they do or who is responsible for them. That's one, and I touched on this. Number 2, something I haven't mentioned, is on the average, only a fraction of a company's assets are covered by vulnerability management at all, probably because we didn't know what assets there were to begin with. So if we had good asset management, we can finally start scanning everything and really know where all the vulnerabilities are that probably are going to get exploited. And the 3rd reason, and this is something that everybody has to get very real about, roughly only half of the vulnerabilities, you look at all the industry reports on who's finding what vulnerabilities and what assets and the remediation rates, only half of all the vulnerabilities that we're finding are getting fixed ever. And when they're fixed, the half-life is 6 months. It takes 6 months to fix these vulnerabilities. The business already understands this. The CISOs already understand this. So one of the reasons we can't get pervasive vulnerability management is because why find more vulnerabilities and more assets that are just not going to get fixed? So again, we're going to need some really good risk management and start filling in these variables that we've been missing all this time. So now the next step is we're going to start pointing the way forward. What's the current way we've been doing things, and what is the better way? How do we do risk management using actual monetary value? So we're going to start very simple and build up. The first one is just a very simple chart. You have asset number 1 versus asset number 2. You find a vulnerability in it. Let me move this out of the way here. You find a vulnerability in it, and in asset number 1, it's red. In asset number 2, it's a vulnerability that's yellow. Just the basic severity. You would say right away, well, you fix the highest criticality ones first. You fix asset number 1 first instead of asset number 2. But let's say we give a little bit more context. Let's say asset number 1, instead of being the main corporate website, is just a test server somewhere. If it's hacked, it would be annoying, but not mission critical. Versus the vulnerability, the yellow rated vulnerabilities in the main website, the main business that might store their brand or take payments. All of a sudden, you reverse the logic. The one you want to test, the one you want to fix and address first is probably the one in the yellow, because that's the main company website, versus the red one. So all of a sudden, just with a little bit of context, we might reverse our logic, but it doesn't stop there. We can go further. So here are the things, and this is just my opinion, that give us really no context of making real good business decisions. So we can have severities like red, yellow, green, high, medium, and low. We can say it scored a B- or a 14 on dread. It's, we have different speedometers and thermometers. All these different ratings, because of what they take into account, really don't give us any guidance on what we should do in what order. Things that would provide better context is if the vulnerability report said, in this asset, there's 430 PII records, or maybe it's in scope of PCI, or if this was hacked, it would be, this website is responsible for $500,000 in business every year. Those contexts, that metadata then becomes useful to making good business decisions. How we do things today, we actually have to justify to the business in, how would I say it, in injection type manner. We need to fix this SQL injection vulnerability in this asset, and the asset is a B- on SSL Labs. These things really have little bearing on to risk for 99% of the companies. The first thing that's going to happen is they're going to go, what's CMDI? What's SQL injection? What's clickjacking? They're going, well, it's this thing that allows you to put in a single quote and a semi-tick, and we might be able to get money out of it. And the business is not, we've all had these conversations. If we can start speaking in dollars and cents, it might be easier. So let's dive into this a little bit. So let's say we are able to give a concrete answer, maybe not concrete, a more context-based answer in terms of liability, meaning the asset in red, this vulnerability is a high severity. If it was exploited, we can expect a $60,000 business loss. If the one in yellow was exploited, we can expect an $800,000 loss. You present that to the business, all of a sudden our logic inverts, and we can start having a more adult conversation about how we do risk management in our industry. It's very easy it's much easier for the owner of that asset, the owner of that website, or the CFO go, yeah, oh, if you hack that vulnerability, we're going to lose that amount of money. Are you sure about that? And then you can go into the monetary math. But this is what we want to angle for, because I think we're going to get much further along at fixing the right vulnerabilities in the right order. So what we're on a mission to do is, not just do attack surface management. What Bit Discovery purports to do is we want to be able to calculate the estimated value of all 6.5 billion assets we're aware of on the internet. Because the data we have has a lot of metadata in it. We know the open ports, we know where it's hosted, the backlinks, the TLS information. If it's revenue generating, we know a lot. So what we want to do is facilitate a conversation between the security teams and the business and say things like, Mr. CFO, we were requesting $300,000 to do X to retire $10 million worth of risk to the business. All of a sudden, that's now a much better conversation than talking about SQL injection and CVSS scores. Now, at this point, usually when I describe these concepts to people, they're like, okay, yeah, but how? Like, how do you get that data? How do you go about it? And in the few more minutes that we have, I'm not going to be able to get into the gory details of it, but I'll give you some thoughts about how we're approaching it. There are things that have sunk costs in it, meaning the web pages and dedicated hosting. We know where the things are hosted, and the business has the bills on how much these things, cost to run. Then there's other things that we can detect from an external perspective that indicates the ongoing costs, meaning are there CDNs, are there cloud providers, things like that. Then there's other pieces of metadata that indicate that there's revenue being trading hands. You could detect things like authentication easy enough. If it has a login screen, then you know it has something to do with login, which might have some regulatory concerns. But if it has shopping carts, ads, dollar signs, and things like that, you can say, okay, that website or that asset looks like it's revenue generating. It's going to be a higher value than perhaps one that isn't. So you can start collecting these pieces of metadata remotely. So then how do you go about calculating ROI? And I'm not going to go through all these things. It's just some ideas that if you want the slides, you can read later. But the idea is that there are ways, and we've been working with a number of economists, hedge fund managers, CFOs, and things like that, getting their feedback. We go, here's an algorithm, how we think we can estimate asset value or estimate liability. And we have these formulas that we're then going to the CFOs and different constituents and say, if we calculated like this, would you agree or disagree? And then we can iterate on these things. So the idea is when we get a good enough model that people like, and some of these things can be adjusted. If the individual company doesn't agree with our default model, they could turn the knobs. They go, well, our brand is worth this much and it's worth far more than a company is. Let's turn that knob up. We don't do a lot of revenue generating things online, so maybe we turn that knob down. So if we give a formula, a model that has the right knobs, the individual company can then estimate the value of their own assets. If they can do that, that's an industry changing win. The customer would then have or a company, I should say, would have a complete list of all their assets and what they do and who's responsible for them, and an indication, a good estimate on the liability of the risk they're taking on and the value of that asset. So now all of a sudden, everybody's looking at the same calculations. They go, well, let's go after these vulnerabilities in these high value assets because those represent the most risk, and focus on those first. If we can do that, and we're going to need some help, but if we can do that, then that's going to be, again, game changing for the entire industry. And then all of a sudden we can, perhaps start spending the right amount of money. One thing one idea I would invite you to ponder. I keep mentioning that our industry spends 150 billion or so a year. Here's the question. If we doubled the spend to 300 billion a year, would our breaches be cut in half? I don't think they would. If we take it the other way and go from 150 to 75 billion, we cut our spend in half, would our breaches double? Probably not. You might disagree, but that's where I'm coming from. That means to me that we're spending a lot in the industry, we're spending a lot of time and energy, but a lot of our energy is probably wasted and working on the wrong things. So rather than continually asking for more and more budget to fix more and more vulnerabilities that will really never get fixed, let alone ever exploited, we should start being more efficient and thoughtful with our spend. And that's how we're going to make real meaningful ground. It's time for InfoSec to evolve and mature like other industries already have ahead of us. We're not the only ones that have had to go through this approach. The auto industry, the airline industry, many industries have had to go, whether it's building and construction, they've had to go through these models. And it's time that software security and InfoSec does the same. So that's what I'm here to advocate for. So what I want to see for the industry and the attack surface management space to push forward, because it's not going to be just bit discovery. We need to know who owns what assets on the internet, because there is no directory for this yet. We need to know the value of every asset in real dollars and cents. And then we can be able to show the risk of an asset using financial metrics. This would be the platform of which what I consider to be the next evolution of information security, and how we push ourselves forward and bring real value to the work that we do. Back to you, Raquel.
Perfect. So we do have a couple of questions that came in for you. Hopefully you are okay to answer them. So the first one we have here is a comment and then the question. So one of the challenges teams encounter when trying to perform asset management or attack risk. Let me try that again. One of the challenges teams encounter when trying to perform asset management or attack surface management is figuring out which system or systems are behind each internet-facing entry point. Sometimes a host might have multiple internet-facing interfaces. Other times, a load balancer might mean that a single entry point might have dozens of hosts beyond it. Would you like to comment on how Bit Discovery helps with attack surface management when it comes to internal and external mappings like this?
That's a fantastic question, and I'm going to have a very disappointing answer, but usually that means that's where the area of innovation is. Generally speaking, whether you're talking an attack surface management company like BitDiscover or anybody that writes a tool, usually the tools that create an attack surface map, an external attack surface map, are completely different than the ones that generate an attack surface map of the internal organization, because the techniques that you use are different. If you're familiar with DAST and SAS, dynamic analysis or static analysis, you know the techniques between the two are different, even though they're both finding vulnerabilities in software. The same is true in attack surface mapping. Secondly, to the question itself, I'll tell you, here's the host name and IP of this asset. Please map it to the internal one. For the most part, it's impossible right now. No one knows a real good, reliable way to do so, because as was mentioned, an internal host could have one or multiple IP internal hosts and might go out, connect out, or outside in to one or more hosts. Really, really hard. There's no good way or product integration I'm aware of today that says this asset, external asset, maps to this internal one. That will have to be solved eventually. And this is where application security was a decade or more ago, before they started to overlap DAST and SAS together. So we're going to have to overlap external and internal eventually. That's where the edge of knowledge is. We'll need smart people working on this one.
Awesome. So our next question here for you is, does Bit Discovery help with changes in the attack surface? Like if an existing web application suddenly has a new input form or a new API endpoint, could that be automatically identified so that it could be automatically tested with an appropriate tool?
Great question. Another one. Okay. Like I mentioned earlier, assets will come and go. That's one type of change. Ports will open and close. That's another change. The software in every port could change. And then there's one very detailed and nuanced aspect of that question, is that a website might make meaningful changes, like they might change the way the cookies are there or new forms and things like that. We can detect the first three fairly reliably with whatever frequency the customer might like. Sometimes every 2 weeks is fine. Sometimes they might want it daily or faster than that. We don't yet have the facilities to detect changes like a new form has popped up. API endpoints, yeah, we've been doing that one for a while. That's not terribly difficult anymore. The next step for us, or one of the next steps, is we want a full crawl of the entire internet. So right now, if you think about it like in Google terms, Google has the entire web, not the internet, the web. So they've crawled everything internally. Bit Discovery has everything else, but what we don't have is the crawl data that Google has. So that we want to get. Once we get that, like we do have some amount of HTML, just the index page, but we want a full crawl of the internet to overlay on our data, and then we'll be able to do what the questioner was asking. That one's coming. So two great forward-thinking questions.
Awesome. And our last question that we have here for you, it's Jeremiah. How do you contrast the approach you've outlined with quantitative risk approaches like FAIR?
FAIR always comes up. Glad it did. So FAIR is good for what it is. The practical answer is, I've had tons of conversations on it. FAIR can work. The problem is it's too hard and it seems to be way too hard for any company to do reliably across all their assets. If we're going to do something like FAIR, maybe it's our model, maybe it's FAIR, we have to find a way to automate the process because the internet is really big and the change rate is all the time. FAIR in its current implementation doesn't seem up to the task. It's just too hard, it's too manual, it's too slow. Even if the outcome is highly accurate, we're not able to implement it.
Awesome. Well, that is it from the audience. Thank you so much for that session. It was great. And thank you for taking the time to answer those questions. If you have any more questions for Jeremiah, he did include his email in the Bit Discovery website, so feel free to check that out.